In this video, we're going to talk about the discriminant. The discriminant is the stuff underneath the radical in the quadratic formula, or b squared minus 4ac. Now, what information does this thing provide? Why do we use it? So, depending on the value of your discriminant, it will tell you the number of roots and the type. So, for example, if the value of your discriminant is positive, greater than 0, and it is a perfect square, you will have two roots and they will be rational. Okay, they'll also be real. Okay, so you will have two real rational roots. If your discriminant is positive and it's not a perfect square, you will still have two roots, but they will be real and irrational. That means that you have a radical as your answer. Okay? Rational means it's a whole number or a fraction. Irrational means that there is a square root somewhere in that answer. If your discriminant is equal to 0, you will only have one root and it will be real and rational. Again, no radicals. If your discriminant is less than 0 or negative, you will have two roots and they will be imaginary. This is where those complex numbers come in. So let's look at a couple examples. So find the discriminant. So we first want to identify our A, B, and C. So here our A is 2, B is 12, and C is negative 13. So we plug this into our discriminant. Remember, the discriminant is b squared minus 4ac. So we will have 12 squared minus 4 times 2 times negative 13. If you punch that into a calculator, you are going to get the number 248. Based on our table in the previous slide, if our discriminant is positive, 248 is not a perfect square, so we will have two real irrational roots, meaning that we will have a radical in our answer. Let's look at this next example. We have 3x squared plus 24. So our A is 3, B is 0, there is not a B, and C is 24. Again, if we plug this into our discriminant, so we have b squared minus 4 times a times c. So if you multiply all of that, you will get negative 288. Again, if you look at our table in the previous slide, you will see that if our discriminant is negative, we will have two imaginary roots. This is because we will try to take the square root of negative 288. Whenever we do that, that negative needs to come out of the square root as an I. So that's what gives us our imaginary number, is because of that negative. So we can use the discriminant to choose the best method to solving a quadratic equation. So let's look at some of these. These are all the methods that you have learned to solve a quadratic equation. So let's look at graphing. Graphing can be used sometimes. It only works if your roots are integers, meaning they are whole numbers, positive or negative. Okay, not very practical. Factoring can be used sometimes when your roots are rational. This means that you either have whole numbers or fractions. Okay, there are no radicals in your answer. Rational numbers, whole numbers, or fractions. Square roots. You can use square roots sometimes, and it only works whenever there is no bx term. Okay, usually this will look like ax squared plus c is equal to 0. That's whenever you can use your square root. Okay. Completing the square can be used always, although it's not very fun. It helps if there is no x squared coefficient. And you need an even bx term. So completing the square, not very easy to do, definitely not my favorite thing, but you can always use it. It will work every time. Last but not least, the quadratic formula. You can use this always and whenever anything else fails. So when all other methods fail. Sometimes people like to use the quadratic formula as their go-to, all right? Because it works every time, you will always be able to find an answer using that quadratic formula. But this is how the discriminant is useful. It can show you how many roots and the type, and then it can show you the method that is going to be best for solving that quadratic equation.